Hi, welcome to another lesson of Algebra 2. Today's lesson, we will be combining lessons 2.1 and 2.2. The first learning objective is we will learn how to solve quadratic equation in factored form using the zero product property. A quadratic function in factored form is one that is written as f of x equals a times x minus r times x minus s, where a, r, and s are real numbers, and this a over here cannot be equal to 0. So the a can be a positive number, it can be a negative number, but it couldn't be a 0. Okay, please remember that. A zero product property, if a times b is equal to 0, please remember that anything multiplied by 0 is equal to 0. So if you have a times b equals 0, then a is equal to 0, or b is equal to 0, or it could be that both a and b are both equal to 0. For example, if you have x minus 1 times x plus 3 equal to 0, so if a is x minus 1 and then the b is x plus 3, either of them could be equal to 0. So what we do is we have x minus 1 equal to 0. So that's x is equal to positive 1, right? We add 1 on both sides. We have x plus 3 equal to 0. We have x is equal to negative 3 because we subtract 3 on both sides. And so we have x is equal to a positive 1 and a negative 3. Okay? And then here are other examples. Let's have x minus 4 and x plus 10. So we have x minus 4 equal to 0. So x is equal to 4 because we add 4 on both sides. And x plus 10 equal to 0. So technically, if I want to show my solution, I would be subtracting 10 on both sides. So I have x is equal to negative 10. So my solution set is negative 10, comma 4. Then for the next example, I could have either the 2x is equal to 0 or the x plus 10 is equal to 0. So that is minus 10 on both sides. So that's x is equal to negative 10. And then divide by 2 on both sides, x is equal to 0. So we have negative 10, comma 0. Okay, moving on. And I think we kind of know the idea of how, let's say if I have x plus 10 equals 0, so x is a negative 10, right? So if we have x plus 9 equals 0, then I know that x is equal to negative 9. So just write negative 9 in there. Later on, we would be like, just by looking at x plus 9, you know that if x is equal to negative 9, you make it equal to 0. So you don't have to like show all of these solutions, right? And then we have 4x plus 1 equal to 0. That's technically minus 1 on both sides if I want to show my solution. And that is 4x equals negative 1. And then I have to divide by 4. So x is equal to negative 1/4. Okay? And that's all for lesson 2.2. Let's go forward to Quadratics 2.2. And we have, I will learn how to determine the intercepts in the vertex of a quadratic function. We will learn how to graph a quadratic function in factor form. That would be later. And then we would also learn how to compare key features of quadratic functions using different representations. So for example, this page or this template is just to remind you where the x-intercepts are. And I think a lot of you or most of you are already familiar with what they are. And hopefully all of you are already familiar where we find the x-intercepts. So we find the x-intercepts along the x-axis. We find another x-intercepts over here. And we call this right here the y-intercept. And the same thing for the next graph. We have the x-intercepts in here, both of them, two x-intercepts, and we have a y-intercept. Now, for this activity, we do not know what this value is, right? Like this could be a positive 1, or that could be a positive 5, depending on how the increments of the line is, right? And this one could be a negative, what, negative 3, or it could be a negative 5. We do not know. But what we do know is that one of the coordinate is 0, right? We know that this one of the coordinate is 0, and I know that this one of the coordinate over here is 0. But where are they? Where is the 0 at? So for an x-intercept, the 0 is on the y-coordinate, right? So both of these are the y-coordinates of the x-intercepts, which is 0. And then for the y-intercept, the x-coordinate or the x value of it is 0. Although I do not know the y because I haven't solved it yet. I do not know the y. I don't know the value of that. I don't know the value of that. But I know one of them is 0. Okay? And same goes through with another graph. So for here, since we know that they are always 0, on the x-coordinate of the y-intercept is always 0, and then the y-coordinate of the x-intercept is always 0. And using this reflection thing in here, hopefully we will learn how to solve the next problem. So the next problem requires us to get the x-intercept and the y-intercept. And because we already know where 0 is located, why don't we just mark it something equals 0, something equals 0? Because I already know where 0 is located, right? And then this one, let's make that a different color. This is 0, comma, I still do not know, and I still have to solve those. Okay? Now, let's start with our x-intercepts. So, for the x-intercept, because this is already factored form, all I have to do is get those numbers inside the parentheses, the factored form. So, we have x minus, let's make that purple. So, we have x minus 1 equals 0, and we know that we just add 1 on both sides, right? So this one is a 1, and let's put the 1 over here, and then let's do x plus 3 equals 0, u minus 3 on both sides, right? And so that's x is equal to negative 3. So our x-intercepts are negative 3 comma 0. So therefore this one right here is a negative 3 comma 0. And this one right here is a 1 comma 0. Right? And now our problem is to get the y-intercept. And we know that the x-coordinate of the y-intercept is always 0. So why don't we do it this way? Why don't we plug in 0 or make the x equal to 0? Right? So you see this x minus 1, I made 0 minus 1, and then that's a 0 plus 3. And all I have to do is follow along. 0 plus 2 is 3, and multiply all together. That's a negative 6. So therefore, my y-intercept is 0 comma negative 6. Okay, how's that? So we got our x-intercepts from this factored form in here. I ignored the 2, right? Because if you make that one, if you put like 2, you're going to divide 2 on both sides. So, and 0 divided by 2 is 0 anyway. So just ignore the a value. Just ignore the number on the outside when you are trying to get the x-intercepts. Just concentrate or focus on the numbers inside the parentheses. But of course, when we get our y-intercept, I am not allowed to ignore the 2. Okay? Let's move on to the next question. I'm not going to spend so much time on this one. It's technically just putting what we did in detail on the previous page. Right? So you can pause the video and fill the blanks in, and then let's move on to number 5. Refer back to the graph of the quadratic function f of x equals 2 times x minus 1 and x plus 3 on the previous page. Based on the graph, what is the vertex and what is the relationship between the zeros of f of x that you found in question 3 and the x coordinate of the vertex? So when you say zeros, that means the x's, right? The x equals something and x equals something. So the zeros we had is a negative 3 and a positive 1. So let me put the numbers in here so we don't get confused. And I think we found that this was a negative 3 comma 0, that's 1 comma 0, and I think this was negative 6, right? Now, the question is, where's the vertex? So let's put the vertex here. This is the vertex, and this is actually also called the minimum value, right? Because remember we call the vertex either, there's two kinds of them. One is called the minimum and one is called the maximum. And minimum means the lowest point of the graph. And because this graph is facing up, we have a minimum value of, we don't know. We don't know yet. Okay? So for here, you are being asked, what's the relationship between the zero? So what's the relationship between, you see this one? What's the relationship between positive 1 and negative 3 in reference to the vertex? What do you guys think? If you look at the x, remember we're talking about the x of the vertex. If you look at the x of the vertex, is it located in the middle of these 2 points right here? Is it? Yes, of course it is, right? So the x coordinate of the vertex is located in the middle of the zeros, or in the two x's. Does that make sense? So if I want to find out the middle number of negative 3 and positive 1, because the numbers are kind of like easy, negative 3 and a positive 1, I think you could, like right now, you could tell what is the number in the middle of negative 3 and a positive 1. And I think if you're confused, you could just technically add the two numbers and divide by 2 to get the number in the middle, right? It's like getting the average, yeah? You add the two numbers and you divide by 2. So what's the average, or what's the number in the middle of negative 3 plus 1? So we have negative 3 plus 1, that is a negative 2. Divide by 2, that's a negative 1. Is it right that the number in between negative 3 and a positive 1 is a negative 1? Yes. And so, the x of our vertex is a negative 1. Now, our problem is, we know that this is negative 1, but we still do not know what the value of the y is. So what we're going to do is I'm going to plug in negative 1 into the given formula. So I'm going to change the x into a negative 1 instead. Right? So we have negative 1 minus 1. Or we have negative 1 plus 3. We have 2. That's a negative 2. That's a positive 2, isn't it? And so the whole thing is negative 8. Therefore, our vertex is at negative 1, comma, negative 8. And I will repeat how I did it. For the blue number, negative 1, I added the two zeros, the two x's, the two x-intercepts at a negative 3 and a positive 1. And the number in the middle of those two is the x of the vertex, which is negative 1. And then I take the negative 1 and plug that into the equation. Okay? I hope that is clear. Let's have more examples. The formula for the function g on the previous page is g of x equals negative 1. Like, miss, I don't see a negative 1. Why are you saying it's negative 1? But remember, like, we don't have to put it if it's just 1, right? So negative 1 times x minus 1 times x minus 5. And here we are being asked to get three different things. So we're being asked to get the x-intercepts, the y-intercept and the vertex. So let's start doing that. Oh, I couldn't see the problem anymore. Okay, here you go. First, let's get the x-intercept. Let's put the color x-intercept in red so that we don't get confused. So we have the x-intercept as x minus 1 equals 0. That is x equals 1. So remember now that the x-intercept is something comma 0, something comma 0, and then let's put 0 comma something. Okay? We have, let's go back to the x-intercept. We have x minus 1 equals 0. You add 1 on both sides, so well, x is equal to 1. And then we have x minus 5 equals 0. And add on both sides, we have x is equal to 5. So that's a 1 and that's a 5. So this is 1 comma 0, 5 comma 0. Okay? I hope that was a little bit better. Okay, let's have our y-intercept in purple. And because the x of the y-intercept is always 0, very good. You guys hopefully are following through. All we have to do is grab the given equation and make all the x's in the given equation 0. Like this one, right? So we have negative 1, we have a negative 5, and I think negative times negative is a positive times another negative that will give us a negative 5. And so the partner of that 0 right there is a negative 5. So all we have to do is, this one is 0 comma negative 5. Yay, very good. And then, what next? Let us get the vertex. So we'll get the vertex. The color of the vertex is blue. And remember, we have x of the vertex and y of the vertex. And we already learned on the previous page that the x of the vertex is the number in the middle of your two x's, right? In the middle of the two x's. Technically, what that means is, what is the number in the middle of 1 and 5? Pretty easy. The number middle of 5, that's a 3, right? Or, as an alternate, you can add the 2 number and divide them by 2. And then let's see. If this is a positive 1, and then this is a positive 5, the middle should be, this is the vertex. And so the middle should be a positive 3, and that's correct, right? And now that I know that the x of my vertex is positive 3, all I have to do is grab the formula and plug in the 3 in it to get the y of the vertex. That's a 2, negative 2. Negative 2 times another negative 2 is a positive 4. And so our y of the vertex, therefore, is a positive 4. And there you go. You have your x-intercepts, which is in red color, coming from making x minus 1 and x minus 5 equal to 0. You got the y-intercept in purple by plugging in a 0. And you got the vertex in blue by getting the x of the vertex first by getting the number in the middle of your two x's and then plug that number into the original equation. Okay, should we practice some more? Let us move on to number 7. We are almost done. Suppose m of x is equal to 2 times x minus 2 times x minus 4, and the graph of the quadratic function n of x is given, which has the smaller minimum value, m or n, and justify your answer. So in here, we're given two different things here, right? We're given that we have a graph called n of x, function n of x, and we have the, what's that called? We have the equation which is called m of x. Well, all we have to do is compare their minimum value. And I think we already learned that long time, last week maybe, that the minimum value is just the vertex, right? So the minimum value is just the vertex, or technically the y of the vertex, or the lowest point of the graph. And because we're comparing two, don't make let's not make it, like super confusing. So let's have it as, okay, what is the vertex of m of x? And then on the other side, what's the vertex of n of x? Okay? And then because the graph of n of x is already given, let's figure out what the vertex is in here. What is that? Is that 1, comma, negative 1? Is it 1, comma, negative 1? Right? And so for m of x, and this one right here, that's the lowest point, right? The y value of the vertex, the y coordinate, is the minimum value, which is a negative 1. So right now, we know that n of x is negative 1. The minimum value of n of x is negative 1. All we have to do now is figure out what's the vertex for m of x. But because we do not have the graph, we're going to have to solve it, right? So let's start with getting the x's. So we have x minus 2 equals 0. I hope I am not too fast for you guys. If I am, you can always just rewind, pause the video, think about it, or come back to our meeting if you're confused. So we have x minus 2 equals 0. So we have x is equal to 2. And then we have x minus 4 equal to 0. We have x is equal to 4. So that's 2 and 4. What is the number in between 2 and 4? So that's 6 divided by 2. That's a 3. Now what am I going to do with the 3? I know that the x of the vertex is 3, but my goal is not just to get the x of the vertex, but to get the y of the vertex. So all I have to do now is grab that number 3 and plug that in back to the original equation. Okay, I hope this is clearer now. We have 2 times 1 times negative 1. That's negative 2. So I'm going to put that in red. And now I am comparing the two minimum values. The minimum value for m of x is negative 2 in red. The minimum value of n of x is negative 1 in red also. Now the question is, which one is smaller minimum value? Which one is lower if you graphed it? Is it the negative 2 or is it the negative 1? And it's kind of obvious that m of x has a smaller minimum value, right? Because negative 2 is lower than negative 1. And this is the full credit of an answer. Okay. I hope this is clear. Your homework today is going to be letters C, D, and E. Your homework and your classwork at the same time will be letters C, D, and E. If you are good to go, you can stop the video and you do the rest on your own. But if not, if you still need one more example, I'm going to do letter B as the last example in this video, and then you guys can do your classwork or homework. Okay? Letter B. Suppose m of x equals negative 2, x minus 3, and x plus 1. And we also have a graph on the G right on the right side. Question is, which one has a smaller maximum? Maximum meaning the highest point of the graph. So maximum means the highest point of the graph. Yeah, and let's do the same thing what we did earlier. So m of x, oh, what happened? m of x is equal to, we don't know yet, and then g of x is equal to, we do know, right? We do know that because we have the graph right here. What is this one? Is that 1 comma 4, right? Okay, 1 comma 4. And remember now, I am only concerned about that number. I'm only concerned about comparing the y value. So m of x is a little bit work, right? Because we have to solve. So we have get the x's first. That's always the first thing we do. X minus 3 equals 0. So that's x equals to 3. X plus 1 equals 0. X is equal to negative 1. And so the x of the vertex, we have to add these numbers and divide by 2. So we have negative 1 plus 3 divide by 2. So that's 2 divided by 2. X is equal to 1. So the x of the vertex for letter B is equal to 1. Now what am I going to do with 1? Like, and then what, right? So all I have to do is grab the original equation and plug in the 1 in the x's. So I will then have negative 2. Is that a negative 2 right there? And a positive 2. Oh, they're all 2. And a negative times a negative is a positive. So altogether, 2 times 2 times 2 is a positive 8. And so, I am now comparing which one has the smaller maximum value. Is it the 4 or is it the 8? And of course, because we're being asked for a smaller maximum value, I would go with 4 as a smaller maximum value. So I would then say, let's put that in black. G of x. G of x has a smaller max value or maximum value because, right, because 4 is lower than 8. And this should be our final answer. Okay, I hope that clears the confusion. And for your classwork and homework at the same time, I am assigning letters C, D, and E on page 44. Thank you guys for listening to this very long video. I will see you on our next lesson. Bye!